Exercise 1.1 of Class 12 NCERT book. Questions on reflexive, symmetric, transitive, and equivalence relations. Show that the relation R in the set 1, 2, 3 given by R is equal to 1, 2, 2, 1 is symmetric but neither reflexive nor transitive. This time the relation is given and the roster form. And that set is a very limited set, only 3 elements. This relation, is it symmetric, reflexive or transitive? Let's see. 1, 2 and 2, 1. These are the only two pairs included in the relation. For a relation to be called reflexive relation, every element of the form A, should belong to the relation. That means here 1, 1 should have been there in the relation, not found. Nor there are 2, 2 and 3, 3. But we need to highlight only one of them as counterexample. 1, 1 does not belong to R. That goes against the definition. For every element it should have been there. So this relation is not reflexive. Symmetric. Whenever there is a pair A, B, then B, A should also be there. It's a conditional statement. If A, B is present, then it should imply that B, A is also there in the relation. Let us check. Let's take 1, 2 as one of the relations, one of the pairs in the relation. 1, 2 and we can see 2, 1 is also there. Or if you take 2, 1 as the first element, its reverse 1, 2 is also there. It's following the condition of this definition. Therefore, this relation is a symmetric relation. One thing to be noted. Do not go on checking whether 1, 3 and 3, 1 are also there. Because the definition says if A, B is there, then B, A should also be there in the relation. Don't go on checking the pairs that are not there in the relation. For each pair A, B that is present in the relation, its reverse element also should be there. So we need to check with the elements that are present in the relation. Now, is it transitive relation? For the relation to be transitive, whenever there are pairs of the form A, B, B, C, A, C also should be there in the relation. Even this is a conditional one. If these two are there, then this should also be there. Now, let's go for two pairs that are in this form having a B common. Take 1, 2 and 2, 1. Both of them follow this rule, having the B as 2 here. Whenever this kind of two pairs are there, for it to be called transitive relation, there should have been 1, 1. This is what A and C here. This A and C, 1, 1 also should have been there in the relation. It's not found. Since that is not found in the relation, this cannot be called a transitive relation. So this relation R is not a transitive relation. So this relation is symmetric. It is symmetric, but neither reflexive nor transitive.